Hello, can you hear me?
Yes, ma'am.
Yeah, so guys, camera please. Can you also turn your cameras? And proper name. Okay, we shall start with today's session. Or maybe we'll wait for 5 more minutes and then we'll start because let me get some numbers. Okay.
Okay.
Okay, hello. Let's start for today's session. Okay, so today we are going to continue with what we have started yesterday. So we started with threads. So we shall continue with the same. Hope you guys remember what we did. Yes.
Yes, ma'am.
Switching to the workspace. I'm switching on my Eclipse, so this might take a while. And we shall continue. Okay. I hope you guys can see my screen. My screen visible to all.
Yes, ma'am.
So if you see in here, we are starting with our day 7, and I suppose you guys are in on the place and you are following what I have asked you to do. So this is your day 7. So this is what we have done yesterday. We created threads wherein we saw how to create different threads by different means. Like I can create a thread by using runnable interface or by using thread class. So either of them can be done. That means I can create a thread by using a class, which is not very much feasible option because if I have to extend some other class into my system, that will cause some or the other issue. So it is better you implement runnable instead of extending a class. So let's do this way. This is the thing that we had. So we used to extend it this way. We can see it extending a class and override the run method, wherein whatever you write within this method will be executed as a thread. So here I have created 3 different threads. I have named it. We have started it. So this start method will implicitly call the run method and will be following thread life cycle. So also thread life cycle was something that we had followed yesterday. Yes, there were some mistakes and there were some things that we need to remember, things that we need to talk about. Okay, so when we talk about life cycle for the born state or the new state, so when we call the start method, born state will be done, and then when the run method is called, this thing goes from runnable to running state. Okay, when yield method is called, this method is going to make the thread go from the running to runnable state. Then you have got wait, sleep, then you also have suspend. That is going to ask the thread to go to block state. Whereas if I want the thread go back into the active state, to the runnable state, then I would say I will call for notify or notify all. Sleep is time based. That means I need to specify what time, for what amount of time a particular thread is supposed to not work. It's supposed to be into a block state. And once the time is over, the particular thread is supposed to go back into the active state. Now, once everything is done, the task given to the thread is done, or maybe it is no longer in use, then it is supposed to go to the dead state by the means of stop method. Okay, so these are all the things which you need to know. Again, the methods. These are all the methods which you have. So you have got start method, which will implicitly call the run method, the wait and notify all method. Basically, it is used along with synchronization. You have sleep, you have yield and join. We'll see purpose and implementation for the both. Then you have got current thread. We have seen one of the implementation, get and set priority, get name, suspend and resume, which are deprecated, which are no longer used. And of course, this is an important concept, which is synchronization. We'll see how can we synchronize a block or we can synchronize a method. So we'll try to do it one at a time. We'll try to execute things, and we'll see how you're supposed to remember all these concepts, because thread as a concept is very important. Okay. Although we might not see any major implementation from our end, but the major concepts or the frameworks which we have for a later part will be implementing these concepts automatically by default. Okay, so let's start with the first concept, that is for working with, let's say I'm cleaning a class here. So we'll go for all the methods for now. Okay. So I am creating threads dot methods. And let's name it. Which method you want to go first? Let's say we'll go for the sleep method, because we need to see what exactly happens. Okay, so we'll go for sleep demo, public static void main, and let's see and execute what is the output. So how to create a thread? We can either extend or we can implement. So for now, I don't have anything major to extend here. So I'll just go with the basic implementation of thread class. So since I've extended thread, I will have to override the run method. Yes, so this is how you override it. Once you have overridden the method, you need to put some definition into it. So let's say I'm simply writing a for loop just to understand how the sequence goes in. So I is equal to 1, I is less than or equal to, let's say, 4, or let's say this time we go up till 7 just to see things. How many times a particular loop is getting iterated for a particular point of time. Yes. And then I am just putting up the value here. We'll say the value is I, just to be printable. First of all, let's create a thread to call this run method. So how do you call it? So I have got my sleep demo object. So I'll be creating a thread T1 is equal to new thread. Okay. And then here I will be creating dot set name. This is how you specify name. I'll name this as T1, that is my thread 1. Okay. And then let's start. So T1 dot start. Okay. And once we start, we just simply have to execute the code. There will be no major changes. Simple thing. 1, 2, 3, 4, 5, 6, 7 will be executed. Yes. So far, it is fine. Now, this is not multi-threading with simple thread, which has been created and which has been used. So I want to go for, let's say, one more thread to be created. So I can also do this. Maybe even this is allowed. Let me just check for this. And I am specifying the name here as no, but I can do this dot set name, and I can directly write it here instead of creating or occupying without. Okay, let's just keep it as it is. So this is T2, T2, and T2. Okay, and here we started. So now if you check, they are going to perform multi-threading because there are 2 threads. Okay, so executing again, and again. Not an issue. It's going as per the sequence. Let's start at once. Okay, so this is for thread 3. From the 3. Okay. Yeah, simple. 1 to 7, 1 to 7, 1 to 7. Resources are not being occupied, so it is very easy for me to say that now you can see the sequence. It is 1 till 7. This is 1 to 6. And then 7 was stopped or halted, and then there was again 1 to 7. But we still don't know which thread is running at a particular point of time. So to know about that, we will be writing a code in here. Let's say thread dot current thread. Current thread is going to fetch the thread which is in execution, which is calling the run method at that particular time. So I'll say get name or get ID, whatever you have given to it. And I can simply print in let's say something like this, or it's with or hyphen or and then value or I for that instance. Let's say T1 is executing till 7, then T2 is starting from in between, let's say from round 3 it's here, then again it's T2, then T2 is here again. Okay, then you can see T3 again will okay, you see that now things again. So T2 is executing at the end, T1 is coming here. T is executing before anything else. So this, what you see is whenever a particular thread gets the resource, it is going to utilize it and execute whatever is mentioned in the run method. The deal here is this, the thing that you see here is called as context switching. Here the context is being switched. That means the thread is getting a resource for a particular instance of time, particular point of time. So I want to make a particular thread to sleep for an instance. Let's say after I am just taking everything together. Let's say here. And this is my thread. Okay. And here I have all the threads starting. So any which ways it is going to work the same way. That is context switching, no order. So now what I'm saying, I want this T2 to sleep for some time. Okay. That means I will have to put this inside a try and catch block because I'm going to interrupt the normal flow of execution. So I will say try and catch block. And here instead of this, I am going to call in for interrupted exception. Yes, because there is going to be an interrupt for the thread. So I can just say e.print stack trace. So I don't have to worry about all the other stuff. So you can see there's an error because I need to catch curves. Okay. Let's do this. T2 dot start. S2 Okay, and then I'm saying T2 dot sleep. Okay, so let's specify this as 4,000. 4,000 is in milliseconds. Now we are getting an error. I need to specify this inside the try and catch I was doing for the start. Okay, now surround this with try and catch block. This is how it goes. Can you see this? Yeah, this is your method. This is how you go. Yes, people. Now what will happen? T1 and T3 will execute, whereas for 4 seconds, T2 is going to sleep. T2 will start, but maybe because it has started and then it has been asked to sleep, then it will perform in this way. Let's see what is going to be the output. Let me just reduce the time. Say I'll just go for 4, just to see this inside the same thing. You can see. Then came in T3 again. It is asking to sleep for some time and then you come again. Okay? So it is sleeping, the resource is sleeping, and then T3 is coming into picture. So it has to perform some context switching, so it will happen at once. Let's say I just take up the execution outside. It will perform a calling. Context switching, you can see the last time it happened, then there was context switching. Master it to sleep again. Maybe after T3 has started. So now it is again going to perform context switching and then will come into the picture. You can see here T1 and T2 are performing, T1 and T3 are performing context switching, but you can see also T2 has started. But because it encountered that it has to sleep for 4 seconds, so it came in later. Again, so here, because of context switching, it might not give you the desired result. So what is happening in here, based on the two algorithms that we have, that is non-preemptive and there is time slicing. Because of these two, it is the resource which has been allocated to the thread is getting context switch. That means each one of them are getting resource for a particular point of time based on the algorithm mentioned. So let me just do this. Now, if you see, again, it will perform context switching and it will give you some of the other result. Okay, now I can make a thread to sleep in this way. Or the other method that I have here is for this one. Let's say, for example, I'll ask the thread. So I want the current thread to sleep. So let's say thread dot current thread dot sleep. Okay, so again, I can specify that in here. And again, this has to be surrounded by some values. Okay, so this is going to be for 2 seconds. And let's surround. Okay, the other method that we have. Okay, something like this. So now it is going to make a thread to sleep for some time and then it is going to call for 2 seconds. So let me just execute, I'll just execute 2 of these threads and not for all. So you can see here. So it is T1 and T2 first thing. And again, sleeping, context switching and sleeping, and this is what you get. Yes. So sleep is going to make. So here, whichever thread is calling, it will make it to sleep. Yes, for 2 seconds each. And then you're getting some output. If you want to check in for this one as well, you can get some output. Let's say you execute. So 2 seconds, one executed. 2 seconds break. Again, context switching. Yes. For each one of them, 2 seconds of break is given and each one of them is executed. This is your sleep method. Yes, people. The next thing which you have here is join method. Let's see what happens if join comes into picture. Okay, we'll be doing the same thing. We will be extending thread. Okay. And we'll just override whatever we had in here. Okay. The or run method. Okay, here we go. We don't need this. We can get rid of this. This is my pure run method. And here I want to execute things as thread. So let's say, for example, this. I will take this here, paste it here. We'll replace this with join. Then let us on. Here we go. Yes, this is done. Let's try executing the code. So if I execute, simple thing working, whatever it was working like before. Okay, this is fine. Now I need to work with join. So what join says? Join says that I am going to ask you to join. That means I'm going to ask you to get into the current execution. Okay, let's say, for example, what I'm saying here. I want to join T1. So I'll say T1.join. Yes. Once I join, I will have to again do the try catch. Let's do the throw. Okay, I don't want to again mess up with anything else. Okay, I'm saying T1.start, then join T1, then you go for T2 and T3. So what is this going to do? First of all, it will finish whatever is there in T1 and then the context switching will happen between T2 and T3. Let's see this. So this is what you have. So T1 is executed normally, whereas T3 and T2 are performing context switching. What if I keep this join method here? Okay. After T1 and T2 has started. So the T1 and T2 will perform the context switching and T3 will be executed at the end. Okay. But it makes sure that T1 should be executed, should be finished before T3 has come into picture. That is the main deal. So if I make T1 to join at the end, after this T1 has T3 has started, then we'll perform the normal context switch. Let's see. If T3 has got anything, see, you can see it will perform in the normal way because it has been asked to perform in the normal way because T3 gets the resource. So if at all it gets a chance, it is going to finish up or wind it up before. Yes, so this is how it is supposed to work. You get this? This is your join method. What is this? Are you trying to write anything onto my screen, Churanshu?
No, ma'am. Extremely sorry, ma'am. Actually, I touched my screen with mistake.
Please clear it.
Hello, ma'am. Good afternoon,
Okay,
Abhinav.
ma'am.
Yes, you're late again.
I'm sorry, ma'am. Actually, I was traveling from Mumbai to Bhopal and I came today itself.
Okay, fine. So the next concept that we have here to join is why we are going for yield demo. Okay, we need public static void main. Yeah, now it is gone. The scratch came in. Because you were trying to annotate. Why were you doing that? Again, so we are going to perform the same thing, extend thread. Okay, then override the run method. We'll do the same thing which we have in here. The run method which I have in here. Let's do a copy and a paste. Okay, you're getting bored, don't worry. I'm going to start with your mock from tomorrow. Okay, so make sure, guys, that you're utilizing your time, that you're sitting here and work accordingly. Yes. So this is your yield. First of all, let's complete this. Okay, join change to yield m is all. And this is my output, the same thing. Okay, so if I execute it, it's going to give me the same output. Let's say this is T1. Yeah. Now, yield says it is going to ask the thread to go from running state to runnable state. That means it is still going to be in active state, but it will push back or hold back into the runnable state. So what happens if I try to do T1 dot yield? Okay. So again, you need to handle throws, interrupted exception. Okay, because the normal execution is interrupted, you'll have to do that. So yield is going to ask this one to go back and let them get the thing first, and then you get into execution. So because of context switching as well, yield is not going to yield a proper output. You can. So let's say what happens if I try to take up this here, T1. So working, but still not clear with what it is doing. So after everything is started, you're asking T1 to yield. That means this particular thing is supposed to be executed at the end. And T2 and T3 are going to perform context switching. This is the basic idea of yield method. Are we good? Yes? So the questions are asked. Can you tell the purpose of yield method, the purpose of sleep method, the purpose of join method? So you should be knowing about them. Yes? Yes, people. We good here?
Yes, ma'am.
Okay, there's one more that we can go through. This is for thread class priority. So we are simply going to finish this up. Refactoring and everything within this will be refactored accordingly. Okay, so what are we doing here? We want to set priorities for the thread. So like I have set name in here, I can also set the priorities. Let's say for this one, there are some types, there are some numbers given to the priority. Let's say set priority. Okay, so you can have a max priority, min priority, or normal priority. So max priority being the highest value, which is 10, min being 1, and normal priority, I think it is between somewhere around 5. I think it starts from 0 to 9. So it goes from 0 to 9. Okay, let's say we go for a normal priority for this one. Okay, So I am setting the priority for this here. Let's say T2 dot set priority again. And then this is max priority. And this one has got the minimum priority. So T3 dot set. Okay, and minimum. Yes. So now what should happen? Since I have given the priority, it is supposed to give the highest priority to T2, and this should execute T2 first. Then it should go for the one with the normal priority, and then at the end, the thread 3 should be entertained. But because I won't be getting the exact result again, because I have got the two underlying algorithms which plays along with the priority. And so let's see what will be the output. You can see thread, yeah. Thread 2 has started, thread 3 started, then 1, 3, 2, and then it is still working, fine. But you can make sure that the thread 2 has been executed before anything else has come on. Again, thread 2 is never supposed to execute at the end. That is the main idea of max priority. So now, again, sometime it does, because I said because of underlying algorithms for thread scheduling. So this is what you have for priorities in it. Are we good? Yes.
Yes, ma'am.
Index switching is always going to be there in the picture. So you need to better have a proper understanding, a proper explanation for all of them. Okay. So these are all the methods. Now let's talk about the next part. Why did I stop? I'm sorry. Let's talk about the next part, which is about synchronization. Now this is important. Okay. Now, in idle scenario, what should be the code and how thread is going to come into picture and how synchronization is going to work in, and how, first of all, we'll go with synchronization using a method for bank operation. We'll go for that first and check how things are supposed to work. Okay, so I am creating a new class called as bank. Okay, this is supposed to be inside. This is for wait and notify. Okay, this example is for wait, notify, demo. Yeah, DEMO. Let's see, I'm creating a bank. Okay, this bank class is supposed to have an amount. So let's say I've got an int, or let's say a double amount. So double amount is equal to, by default, the account is supposed to have 5,000 into it. So I'm keeping some amount. Now, this bank is supposed to do two things. One, it is supposed to perform the withdraw operation. Yes. Withdraw amount. Yes. So whenever a withdraw is called, an amount is supposed to be passed for the same. So I'm supposed to give out name. So I'm just going to give the same name. Okay. The next operation is void. Let's say for withdraw, and then I have to say deposit. Deposit amount. These are the two things. Again, this amount has to be passed whenever this method is called. So int amount. So mind you guys, the amount in the parameters of the method are local variable, while this is the global variable to be accessed within the class. And the scope for this is within the method only. So when I say withdraw is supposed to take out some amount from this amount. Yes. So to access this amount, I'll say this dot amount is equal to this dot amount minus the amount which we have, minus the amount from this. So this amount has to be subtracted from the actual amount, and we'll be getting some output. So I'll say amount. Okay. And I'll say the balance after withdraw is, say, plus, and then this dot amount has to be displayed. Yes, a minus operation, because we need to withdraw. The same thing instead of this, I need to specify that we are performing an addition. Yes, because we are depositing amount. So I will say that the balance after deposit is this dot amount. Yes, so far so good. Yes, people. We good here?
Yes, ma'am.
Now, let's create a test method, or let's say I'm creating a class, or let's say ABC Bank. Okay, this is the bank which I have, and I need to perform the operation. Okay, so I'm having the main method, and I shall work with context to bank. So let's say I am creating a thread. So I am creating a thread T1, one thread, or let's say I'll just do it without thread, and then we'll assign it to thread. So I am creating an object for bank. So let's say bank is equal to new bank. And this bank object is supposed to call the method, that is bank dot, what do you have? Bank dot withdraw. Let's say I want to withdraw 5,000. Okay, this is more. And bank dot deposit. Again, the same amount. So what it is supposed to do, when I say withdraw, I'm just calling withdraw. The function is supposed to give me the balance after withdraw is 0, because there was 5,000 in my account and I tried to remove 5,000. So this amount right now is supposed to hold 5,000 and it is going to give me the amount as 0. So now if I try to deposit, so this is what we get. Yes. We get the deposit again. So we are again depositing this. What if instead of calling this withdraw amount here, okay, let's say I'm just copying it. I call it after maybe say, let's do this. Okay. Okay. I am trying to take out 10,000. Okay. So what I have here is 5,000, but as for this, I want to withdraw 10,000. Okay. So if I try to execute this withdrawal, it is still going to work and will give me the output in negative. Yes, which is incorrect. My account data cannot go in negative. Yes. So if I also try to execute the deposit amount in execute, it is going to show me the data, and later on it will be positive because I have asked it to deposit the amount. So in short, I should not withdraw the amount, withdraw the amount from the bank unless and until a certain amount has been deposited equal to the amount which I wish to withdraw. Yes. So what I'm going to do here is I'm going to check. I'm just going to have an if-else condition. Okay. So I'll check if this dot amount is less than the amount which I wish to remove. Okay. Then I would say you wait. Yes, you wait. So this is here. This is where wait comes into picture. So, but I want this particular thing to work as a thread. So this call has to be there, has to be done from the thread, right? So now let's come up to the concept called as anonymous method, anonymous class. Let's see how this works. So what I'm doing, I'm creating a thread in here. Let's say this is a thread T1 is equal to new thread. Okay, and I am going to call for an anonymous class. So this is what it is. Semicolon. So what I'm doing, I am creating a class, okay, class object, and I want the run method for this one to perform some task. Okay, so the task which I wanted to do is this. Okay, so instead of extending this into some other class like what we did in here, like this. So I have to extend this into class, override the run method and write what I wanted to do, and then call this inside, and then we start the thread. Instead of doing this, what I did is I did it in this way. Yes. This is your anonymous concept. So I can just directly say the method T1 has got into execution, T1 dot start. Yes, this is how it works. So everything that I had. So first of all, extending this whole class has been interpreted into a single block. This is your anonymous object, anonymous class. Yes, you don't have a class name here. You're directly doing it. So this is giving me an error because I need to handle it. So now let's see what is. There's no suggestion to not convert void to thread. Okay. It should work, but it does not. So let's do this. T1 dot start. Yes, this is how it is supposed to be. So now if I want to call this one again, I will have to call another thread to perform the task. So now this is supposed to be T2. Now instead of calling the withdraw, now it is going to call the deposit. Yes, and here it is T2 dot start. So I've got two threads. One thread is to perform the withdraw operation and the other thread to perform the deposit operation. So now let's try to work in the same pattern in the simple scenario. So I have got one thread. Where do I have N? Okay, yeah. So for now. Okay, so this one thread is performing withdraw, but after withdraw, I have got balance after withdraw is 5,000 because this came in before and then started executing. So again, let me just execute. So because it was thread again, so withdraw came in first because T1 dot start got executed, and then T2. Again, if I try to execute, it might not give me the same output. Yes, after withdraw, ideally it should be 0, like the previous scenario. So I need to maintain this, right? It should be one thread at a particular point of time to get into execution, right? So for this scenario, I need to make it into I need to synchronize it. So I'll say synchronized. Yes. Again, over for this one. It's a synchronized. So now let's see what happens. Let's close this. So now let's see what will happen if I call for this. Because it is synchronized, it is going to go in sequence. You execute it again. Execute again. It will go in sequence. What will happen now if it is this? It is still going to go in sequence and give me the negative output. Not good. Yes. So I need to ask here. Now this will come into picture. I will ask it to wait. Wait is supposed to wait. Let's say we'll just add in for the declaration. So here it is going to wait. So if the amount is less than the amount which I want to enter, then it is going to wait. Otherwise, it is going to go for the normal thing. So when is this wait supposed to resume? Whenever I am adding the amount and I'm notifying it. So I'll ask it to notify. Yes, you deposit the amount, the amount after deposit should be something, and then you notify. So whichever threads were into wait state will get back on track. So now because I have added this, surrounded it with this, so I need to also add this. Okay, let me just do it here. Otherwise, I'll have to do it. Then it will throw everywhere the declaration has to go. So let me surround this with try and catch block. Okay, so I don't have to do it everywhere. So now we go in this and then we try to execute. Let's say, let's go for the normal scenario. This is good. Yes. So after withdrawal, it has to be 0 because I'm trying to minus 5,000. And then after deposit has to be 5,000 because that is what is left, 0 plus 5,000. Now let's try to add in, try to withdraw this amount. Okay. So now it is not calling wait. Now it is supposed to notify me, right? So let's notify it here. Okay. I am going to say, you do not have enough balance. Okay. So I'll say calling for deposit. Deposit is very good. And then it will call deposit, and then you'll say here depositing amount. Depositing plus amount which I have. And then so it is saying you do not have enough balance. Calling for deposit. Now it is depositing 5,000. The balance after deposit is this much, and the balance after withdrawal is this much. So once this is done, I can just say here. Okay. Maybe after this notifies, I cannot know. Okay. The balance after deposit is this, and it is because notified was called. Now it is going to call the wait, the thread which was on wait, and this will be excluded. So it is calling everything that I had in here. Yes, people, you get this?
Yes.
Yes, guys. This is your notify wait synchronized. Yes, synchronization and everything. This is how it works. You good? So if I want a
Yes, ma'am.
particular thread to execute in sequence and not perform context switching, then I go for synchronized block or synchronized method. Are we good? Yes. So this completes. I think I can show you an example here. If you can understand the editing. I hope you will understand. Let's see. Okay. So I have got a table. Okay. And this is where let's change package to what I have here. So I've got a table. This is a synchronized method. It is supposed to print me on the sleep of 0.4 seconds. It is supposed to print me the table of 5, or maybe say a table of some number. Okay, whichever number is supposed to put in. Okay, so there will be a number, and then there has to be a table for it. Then there is one thread created, which is extending the thread, and it is in this, we are calling the table, okay, and we are executing the print table method, and we are passing on some value. So this is one way for doing it, which we did, okay. Here we already did it. Here we tried to do everything within the anonymous method, something like this. So instead of doing this, I can also create one class and extend and then perform the whole task. Instead of that, I can directly go for the simple anonymous class name. Yes, I don't have a class name. I'm directly working. Yes, this is the other way around. So there's one more thread, which is supposed to call the method to print the table. Yes, and then there's one with A. This is with synchronous. I can just call it. Okay, I can directly go to synchronization for this one. This is how we deal with it. We'll see for that A later. This is what we have. So now I simply have to create an object and pass on the object to both the threads, that is thread T1 and T2, which was created, and then start them. So if I execute it, it is going to work in sequence and give me some output. So what it is doing, it is calling for table of. So this thread has to create the table of 5. This thread has to create the table of 100. So if I want it to be more sequence, let's say I can just print it accordingly. Let's say n plus multiplied by, right? So I'll go for an x, here's something like this, plus I plus equal to, and this is how it is supposed to print me. Let's see the output again. 5 ones are 5, 5 twos are, and so on. Yes. So if I don't specify synchronized word here, what it should do should still work as a thread, because it is thread. It is supposed to give me some context switching, right? You can see the context switching here. They're not going synchronously. Okay, although the object is same, my data is not synchronized, so my thread is going to work in the context switching manner, the pattern which it is supposed to work. Yes, you get this? So once I make it synchronized, if I try to execute it, it is going to give me a proper output. So first, the first thread which was called, and then the second one, whichever gets the sequence. Yes. So if I don't want to do this whole drama of creating my thread 1, my thread 2, and test thing, then again, I can go for the asynchronous for this anonymous class. Yeah. So I can create an object, the same thing that we did. Okay, the only object which we have. And then I've got one anonymous class object, and this is the another. Yes. So each of them are going to perform the same task. And if I execute, it is going to give me the same output. Okay, so it is up to you. You want to extend your code, or you want to go for the smaller portions. Yes. This was for your synchronized method. The same way, this thread can be in the form of synchronized block. That's it. The table which you have will be in the block. Let me just show you that. Okay, so sorry. The same example, I'm just putting it here. So now this table, instead of having this inside a method, now it is, I have got this print method to contain a block. Yes, so a block, this is nothing but a pointer to the current object, and this will work normally. This will function normally. You get this, people, everything remains the same. You want to check, so this is my thread 1. So I just have to call it with this object. So I just have to give this object, and then it is going to work. Okay. Okay. Let me just take this and copy paste. Otherwise, I have to wait for the indices show up and perform for me. Okay, and this is thread 2. This is your normal scenario wherein you're not performing anonymous class, anonymous method, anonymous object. Yeah, everything remains the same. And this is for anonymous thing. Here we go. Get it? Yes, people? Do you understand thread? So this is everything that you should be knowing about. If you have something else that can prepare you for the same, please kindly do the needful. We good here?
Ma'am, are you going to teach multi-threading in Java?
I thought I'm done with multi-threading. Okay, that's it for the threads. We'll take a break here for 5 to 10 minutes, and then we'll continue later. And we'll start with the remaining portion of the remaining part that you wish to work with. Yes, and from tomorrow onwards, you'll be having mock interviews for module 1, 2, and 3. Make sure you guys are preparing for the same. I'll tell you what you need to prepare. Okay, let's continue. Yes, people. So now there are some topics, some minor topics which are really important for Java again. So we have almost completed all the major concepts. Like if I start from module one, we did data structures. We did the basics of Java, including the tokens and everything. Let's say we also did what are the various data types and what are the questions that might come in. I have already conveyed you the deal, what all things you need to know about it. We have done and strings. I am talking from practical perspectives as well. Okay. Now this completed module one. There are some fewer topics. There are some topics that you should be knowing. So I will be just telling you those extra topics again. So we'll just add it here. Let's say these are extras. So I'll say these are important but extras. .ml extras, or these are the terms. These are something that you need to know. So the first topic we have here, let me just name them. And then if I miss anything, you can let me know. Okay. So we have got one topic such as wrapper classes. Okay, which includes the concept of auto boxing and unboxing. This was asked in one of the interviews. So you should be knowing about this. So I'll just name this as info for extra. This is supposed to be 7 and okay. So the next thing that you should be knowing about is if I'm missing anything, just let me know. This keyword, okay, there are some keywords which are very important that you might encounter. From module one, there is this keyword, then there's finder, then there is static. Okay, all these keywords has been asked. They have asked people, they have asked candidates for these keywords to give an example, the explanation and everything. So the next thing that you can go for from module two, you have super. Okay, then you can let me know, guys, if you can sum up with something. Okay, we see most of the return types. Okay, there's one concept which is called as typecasting. Okay. Then there is one concept. So whatever time we have here, which reason for that reason, this keyword. Okay, there's something called as inner classes. Okay, we'll go for that. Of course, we did not go for anonymous, ANN, anonymous class spelling. Anonymous, you have got anonymous class, anonymous object, anonymous method. We'll see for these things how they work. Okay, then constructors. Wrapper classes, we have seen it already. Now, this was all of module one. From module two, I'm just talking here about the practical implementations that we need to work for. Module two, I think I have covered almost everything, except for the theoretical concept, which is for memory model dry and solid principle. I want you guys to go through this one. This is something which is implemented by by the developers or programmers based on the project that they're working with. So you can just go through those theoretical concepts. Okay. Then I think even this seems if even module 3 is fine. So I think these are the concepts which we need to do. There are a few more concepts that I never did. That was cloning. Okay. Then there was something with comparator. Okay, then there was the concept which I had asked you to do for generics. Okay, then there was a concept for because I've asked you guys to do it. You have not done it, then I have to do it. There's also one more thing which is very common. These are 3 concepts. If you wish, you can add some more. I have also asked you to go for this one. If not, then I'm asking you to go for now. Okay, this is something that you are going to come up with. Okay, this is the task. And the other thing, I'll just talk to you about it. Okay, one by one. Yes, people, we'll see these concepts, how they work, and how we can work into our system. So let's say, for example, we are creating a class here for auto boxing unboxing. So let's say I'll call this as boxing ing. So what is boxing exactly? What is auto boxing? What is unboxing? So let's say, for example, I have got some set of data with me, or let's say I've got some data with me, and this data is enough primitive. Let's say I've got some I is equal to 10, or let's say double is equal to some value. It is into primitive type. Now, because they are in primitive type, it is difficult for me to perform any manipulation operation, or maybe if I want to perform some more operations onto it at the standard level, at the object-oriented level, becomes difficult. It is not possible for the primitive types. Hence, we will have to convert that data. We'll have to wrap it up. We'll have to wrap that data from being from the primitive type to the object type. This is called as autobox. Whereas when you do the reverse process of extracting the data from the object to the primitive type again, then that is called as unboxing. Let's see how this works, how it is supposed to be. So here comes the question of is Java or object-oriented programming language? So it is because Java supports primitive types. Your data, your Java programming language is not a pure object-oriented programming language. Okay, so let's say I've created int I is equal to 10. This is with some value. Yeah. What I'm doing, I want to convert, I need to auto box or box it into an object. So there are corresponding classes, wrapper classes present for boxing up the data. So for int, we have got the data, the wrapper class called as integer. So I'll say is equal to new integer, and I can pass the value y. So this is going to convert the data. Yes. So now if I try to print the value again, it is going to give me the same data. Let's say, for example, I'm printing the value y. It will work. Or if I try to print the value of integer, do you think it is supposed to give me some output? Yeah, let's see. So this is for, let's say, I is equal to the value plus, and this is integer equal to some value. Okay. Both of them are working. Yes. So what is the difference here? If I try to do I and then I try to do some dot, okay, and I'll try to get some intelligence, some functions to work here. It's difficult. But when I do it here, I've got a lot of functions that I can work with. Yeah, a lot of things that I can work with on this particular object. being the data, I have got the same amount of data, I've got the same type of data. The only thing is now I can perform a lot of tasks on it. You can just check it from there. Yes, which was not possible for us to perform on the primitive time. Hence, autoboxing. Hence, boxing. So if I don't do this, and I still want to convert the data into some primitive type, into some object type, then I can also try to do integer is equal to new integer and the value 100. Yes, it will still work. So it is converting the value directly into the object type. So even this is going to. Yes. So what is happening? So if I have to give you a picture, a mental picture of the thing. So there is a box which holds the value 10 for this line, for which the name of that particular box is I. Okay. But when I create an object of a particular object, then a huge box is created within the memory. Now, this particular, let's not call it a box, a container is created into the memory, heap memory, which will hold a location for integer. So if I'm saying I has been assigned to integer, so this integer block or the integer container will hold a small piece of block, which is going to have the value 10 into it. Yes, if I have to give you a good mental picture, let me just not do it this way. Let me just show it to you how it is. Okay. Always diagrams are going to help. So let's say I want to go for autoboxing. Here, this is number. Let me get you a good picture. We don't have one. There was one. So let's start. So same job. Yeah. Maybe this will do something. This is a YouTube exam. This is for unboxing. Need to check for unboxing. Let me just check again. Okay, you all can edit it. So let's see how this works. So when I write int I is equal to 1, a block is created. This is supposed to hold the value 10. And the name for this is going to be I. Let's say I go up for text. And I say this will be I. Okay. When I say integer, a block, okay, a particular block. So this is my heap memory again. Okay, let's undo this. We have that to have. Yeah. So here we are going to have a block. Let's say this is my heap memory that we are talking about. So within this, I am going to have a block which will hold the value 10. Okay, and the name for which is I. Let's take it out. The name for which is I. And this particular thing has been pointing to the name that we have. And the name that we are referring to here is integer. Integer. Yes, this is how it goes. This is an object reference, how it is created. So this is boxing, converting a primitive type. So this is your primitive type that you have. Okay. I'm using this for the first time. I'm not sure. Yeah, black colors. So we are converting this primitive type that you see into object type. So this whole thing becomes an object. This whole thing is an object. Now, if I have to do the vice versa, that means I wish to only extract what we have in here. That means, again, I need to extract this data and convert it into a primitive type. That is called as unboxing. So how do we do that? Okay. So let's say, okay, I know how to do that. Let's say we'll go for stopping this share pouch. Okay. So we'll go for, where is it? Yeah. There. Yeah. So here you can see. Now, if I need to unbox, I will create an integer in, let's say this is new I is equal to 92 extract. So I will say integer dot, okay, int value. And I'll print the new value, which I have with me. So let's see, this is a statement. I can just check, yeah, this one. So this new I is equal to I. And this is called as unboxing, converting an object type back to the primitive type. So again, now if I try to do something onto it, it is not possible. You cannot manipulate or perform any other operation. Yes. So this is auto boxing here. And this unbox. Yes, there's one more way you can do it. Not really sure. Let's try. Let's say I can also write integer dot um value or value of I. I can do this as well. Yes, and if I try to just print the value, even this will perform the auto press. Okay. So I can just check this is one of the type, and this is what we have done. Okay, people. So they are going to ask you to explain what is auto boxing and unboxing, and some pretty examples to explain the same. So for this one, we have got a lot of wrapper classes associated with it. Let's say, for example, here I am going to have, okay, for int, the corresponding wrapper class is integer. Yes, for a char, the corresponding wrapper class is character. For all the primitive types, for double, we have double. Then for, to remember any, can you start it up? Yes, so like this, the list goes on. So these are your wrapper classes. Integer, character, double are called as your wrapper classes, which helps you to convert your primitive type into object type. And unboxing is converting or extracting your primitive type from extracting your primitive data from your object data, or converting your object type into primitive type. You get this, everyone? Yes, guys. Yes or no? I am talking to people, those who are not interested.
Yes,
Is
ma'am.
that the case?
Yes, ma'am. Yes.
Okay. Let's continue with the next portion. Okay, so the next one is typecasting. Again, typecasting, we do the same thing. Let's see what is typecasting all about. Typecasting is converting from one type to another. Let's see how this works. Okay, so I would require a main method. So I have one integer type. I is equal to 10, or maybe say 1, 2, 3, 4. I have a double wherein my E value is 12.24. Okay, this is what we do. Yes, we have char, which is something like C is equal to single character A. Yes, or float. Let's see, I'll create a float. How do you create a float? The default data type for decimals is double, hence we have to again typecast it. So comes one of the thing. So I can say F is equal to 3.14, and then it will be giving me some error. So I have to just do an F, and it will work. It is an automatic thing which can work. Now, for integer, the other types which I have, the other things, the other corresponding data types which we have is byte, okay, followed by int. Then there is something called, followed by short. Okay, then there's something called as int. Then comes in long. Yes, this is all the thing that we double has got only, let's say, float. It has a double, maybe it also has long double. Then char is independent, float we know about it. So this is one of the methods to typecast. Okay, one method. Let's say I want to go for one more thing. I'm trying to adjust. So what is this doing? This is converting your float type of data into double data. If you don't do this, let's say I want to convert this into double. So I can just do, let's say, B equals to F. If I do that, it will work. Yes. So maybe if I want to, let's not do for this one. I'm doing B is equal to I. What will this do? Okay. It is simply going to convert my integer type now to double type. So if I have to print the value of I, let's see, what is the value? So, okay. So I value of I. Then there is the value for B, and then there's some more value that I want to see. Yes, let's see the output for now. We'll go for this later. Yes, the simple thing that I have given in here. Okay, so now if I try to write double for this one, yeah, this is one of the ways. This is your typecasting the particular data into some other format. You see, some other format is double type. Yes, now your data has been implicitly typecasted to double. Yes, if I explicitly typecasted to double. So, but if instead of doing that, if I do this, we can now check the value for D will be changed in here. So before it was 12.24. Now it is going to be changed to this explicit typecast, similar to what we have done. Yes, explicitly specifying what this particular type is supposed to be, and otherwise assigning it to the value. So this is done automatically. So this is from upper type to lower type. So if I want to do something like I is equal to D, okay, wherein now my D value is, let's say I need to just put in some decimal value, right? So I have got 12.36, some value in here, right? And I want to print the value of 5. So it is not going to allow me, first of all. It is saying that I cannot convert my data into any of this type. So it is not possible for you to convert this data. So again, you might have to perform this. So what is this supposed to do? This is only going to give me the value which I need. Okay, the int part of that number. That means it is only going to give me 12, and the decimals and all the rest of the numbers are removed. You get this? So there are various combinations. you can go from the upper type to the lower type and from lower type to the upper type. If you go from the lower type to the upper type, that means from, let's say, you're converting your lower type into some upper type, then no data loss is done. You don't have any data loss. But if you convert your lower type, your higher data types into lower types, then there are chances of losing data. So like here, the data has been lost. Yes. So when we talk about characters, you can see here you have got a character. So simply it is printing you some value. But if I change it to some type, let's say int, what is this supposed to give me? An integer. I'm casting my character data into an integer type. This is supposed to give me the ASCII value of that particular character, which is 65 for this instance. Yes. So if I change it to something else, let's say for let's say 8, it is again a character which has got an ASCII value in the ASCII table, and the value is 56. You get the point, people? This is the simple typecasting of primitive types. Now, typecasting can be done for the object types as well. Typecasting can be done for parent-child relationship as well. This is just for your basic understanding. I'll be sharing this to you, so be having everything in your hand. Let's talk about some of the keywords, and then from tomorrow, so rest of the part, I think you guys are going to do, I will be able to go for everything. Anonymous method is something, anonymous class object method is something that I've taught already. So I won't be going ahead with the same, unless and until you want me to go ahead for this explicitly. Let's go for these keywords. Okay. Let's say I am creating a new class here. Okay, I will call this as employee. Okay, I have public static void main. Now what I'm doing, I am creating the constructor. Okay, let's take a simple example of constructor. So first of all, I have got int ID, and I've got string name. These are the two things which I have. And I'm creating a constructor. How do you create a constructor? If you create a constructor, something like this is your default constructor. You can just simply give in the value, let's say ID is equal to 101, and let's say name is equal to some other value. I see here this is ML, Millionlights. Yeah. So if I have to work with this, I am simply going to say employee is equal to new employee, and we'll be getting some value. So I just have to give in, let's say, the value. I just have to call this default constructor. It will be called automatically. Now, what is the proper name is equal to? I'm not sure. Yes. So if I have to print the value, I need to have a toString method overridden. So how do you do that? I'll say toString. Okay. So this will come in here, and I want to print what it is supposed to return to me. So I want this return statement to return me the employee object value. So I will say employee ID. Okay, and let's say is equal to, and then double inverted plus, and then say I'll say ID plus double inverted backslash n. It is going to go in the new line, and I'll say employee name. Sorry, and is equal to plus name. And this is what it is supposed to print me. So I'm just going to write a simple statement that will print me the employee value. So I don't have to write the whole thing again and again. So there's a simple way to show up the value in your system. So this is how it works. Yes, let's check it again. So now where this comes into picture, let's say we are trying to implement parameterized constructor. So here, I'm again going to have an employee. But this employee is supposed to contain the value, let's say, int I, comma, string n. And what I'm going to do is I'll say ID is equal to I, because I need to assign whatever value I have here to this one, so that whatever other methods are using the ID and name should be accessing the value with which it has been initialized with. So it has to be in this way, something like this. And then I create another object. Let's say employee 1 is equal to new employee. New employee. And now let's try to add some values. So I'll say 1001, comma, this is Neha. This is my output, and let's say we'll print the value for employee 1. Yes, would work fine for me, not a big deal, because what I'm doing here, whatever value I have presented in here will go to Y, and the value which I have in here will go to N. And I'm assigning to I and N, ID and name, which is getting printed to this particular method using to string. Yeah, I'm simply printing the value. Yes. So now what happens, instead of writing I and N, I write ID and name to be more specific, right? Because I need to know what these variables are supposed to be. So now, because of that key, now this becomes ID and name. So now the confusion comes in, which ID is which one? Because as per the syntax, it is okay. It is clear to me that one of this ID, the one which is to the right hand side of the equal to, is supposed to assign the value to the left hand side. But my idea here is I need to assign the ID of this class to whatever ID value is coming for this particular method, right? So I need to say whenever this instance, okay, whenever this instance is called with these two values, it is supposed to get the value to this particular instance, whichever object is calling it. So I will have to say this, the calling object, that is employee to ID, and name has to go to 101 and name, or whatever that was. So I'll say this. This refers to the instance or the reference of the calling object. Yes, guys? You understand this? Yes, people. This is used to differentiate between the reference which has been called and the other variables which we have. So we can use this along with any of these. We can also have this with the method. Okay, like I can have, I can call it this way. Let's say, for example, I'm calling this. Okay. Yes. So this is going to call the current object constructor, something like that. Okay, let's see what is going to be. Yeah. Okay, nothing. But it's just calling this. I want to call it. Okay, I can also have this inside this. So this is basically going to refer to the current object reference. Okay, let's not confuse. This is the basic simple explanation for this that you can refer to. Now, let's say, for example, I want to go for final. Okay, I'm creating a class here. This class is, let's say, a test class. Okay, this contains public static void main, and say finish. Okay, 3 things can be made final. Okay, I can have a final class or method, or let's say a variable, a member. Yes. So here I am trying to create one add method, a simple class. Okay, I'm creating a class called as add, and this class, or let's say op, and I am having an integer variable, so some, or let's say some answer. And for now, it has to be initialized to 0. And now I'm creating a void method, void add, and it is supposed to add in some value. Let's say I am performing some add in here. Answer is equal to, let's say, 10 plus 20. This is what I have. Simple operation. Now, inside my public static void main of the test class, I will just have to take the object of the class and work. Let's say I am performing an extends. Okay, let's do this. Extends off. Okay, I don't have to even do anything else. I just have to call the test object and call the add method. Okay, so, and I will also print the value for answer. Okay, simple operation. So test test is equal to new test. You understand what I'm doing here? I'm simply calling the method. I'm just performing a simple add operation. Add. Yes. Let's see the output. Right now, there's no final thing implemented. A simple scenario. 30 is the output, which is correct. Now, let's make our variable final. So once you make it final, you cannot change it. Okay, once a variable is declared final, it cannot be redefined. Answer cannot be assigned because answer has already been assigned to some value. Yes, this is one way. This is one thing that you have. Okay. Okay, let's keep it for the normal thing right now. What if we make our method final? Okay. For now, let's keep it this way. And let's say, because I'm extending, I'm trying to override the void method, the void add method, which I have because I'm extending. So I am simply going to write the value for answer. Whatever I had here, I'll be changing it to something else. Okay. Let's say it is supposed to give me 20 plus 20. And the answer is supposed to be displayed. And if I call it, it is supposed to call the method from my overridden class. Yes, so this is what I'm supposed to get. But if I make this as final, yeah, so this will give me an error. Cannot override a final method from this class. So if I make my method final, I cannot override it. As simple as that. Yes, this is again one of the deals. And let's say, what happens if you make your class final? If you do final, cannot extend it. This is going to give you an error. So everything that you have inside that particular class is not accessible because extension is not possible. We cannot subclasses. So to restrict a class from being subclassed, we make use of final keyword. Yes, people. So these are all the various types which you have for final. So again, you can come up with your own examples during the time of the interview and make sure that you are good to go with. Yes, why do I have this error? Because of this term. Okay. Good people. So I shall end up here. The rest of the topics, I suppose that you guys can do it at your end. So I'll be sharing this whole thing to you on the chat so that you can refer to it and work accordingly. So do you have any doubt that you wish to ask me? Just keep me.
No, ma'am, not at all.
How about others? Good, you don't have any. How about others? Do you guys wish to respond anytime to me? Yes, people. So, okay. I'm not getting the data I have. Okay. No, ma'am. Who is KP? KP, what is your full name? Why do you have KNP associated with your name? Yes. Can you show me your face? It is for everyone. It is not only for him, it is for everyone. Please show me your faces. I need to know who I'm teaching to. Okay, I think, okay, Mani, you were not there in between. Okay, so please download. If everybody is done downloading, just let me know. I'll It is only after that I'll end up the session. So tomorrow you guys are supposed to prepare yourself for module 1, 2, and 3. Prepare yourself because from tomorrow onwards, we are going to start the mock interviews. Yes,
Ma'am,
because all which I wish to discuss or talk about has been completed already. Yes.
ma'am, tomorrow there will be a mock interview, not real interview, right?
Yeah, mock interview. You're not going to go for the real interview directly. You have to wait for some
Real
time.
interviews will have in July. Will happen in July.
I'm not aware about that. I only
Actually,
know that
in the group, it was circulated that real interviews will happen in July.
great. Still, you don't have a lot of time. You know, Java is huge.
Yeah.
You have got projects and everything. We
Yeah.
need to work upon. Yes, and also from tomorrow, we are going to start with our projects. Yes. So you need to prepare for the same. I'll give you a basic introduction about it. What you can think, you just have to think over it. If a project idea is given to you, how you're going to work along. So we'll be having mocks and introduction to your project. Yes, so as and when we continue with our project, we'll be having an idea what all concepts needs to be implemented for the same. Yes, people.
Okay, ma'am.
So if you guys have downloaded, I shall end up the session. That's it from my end. Done with downloading?
Yes, ma'am.
Oh. About others? Abhinav, Kadia, and Karan. Downloaded?
Yes, ma'am, I have downloaded.
Okay, great. So see you guys